Welcome to Coda Media. Today it is a class of organic chemistry about the hydrocarbons. This is the start of it. The name itself is self-explanatory. What is hydrocarbons? It is a compound whose majority of elements are hydrogen and carbons. So, organic compounds are the hydrocarbons. Their derivatives and branch of chemistry that deal with the study of this compound is known as organic chemistry. The organic chemistry is what? It is a compound of hydrocarbons and their derivatives. Hydrocarbon means you know the element carbon and hydrogen. And the combination of carbon and hydrogen with other element where majority are the carbon and hydrogens. The ratio of the carbon and hydrogen with the other elements is called the derivatives, which follow certain rules. The composition element mostly are the fluorine, chlorine, bromine, iodine. These are mostly the inorganic compounds. So, these are the very less in quantity, although in an organic compound the inorganic elements are very less in number, but it making some meaning. In organic compound, the elements are linked with covalent bond, mostly the covalent bond. The covalent means what? This covalent bond and with the helping of this covalent bond they are sharing the electrons. Inorganic compound they mostly make the ionic bond to transfer electrons from one to another. They can make it to form a compound, organic compound. The solubility of the organic compound generally are non-polar in nature. And soluble in non-polar solvents such as benzene, carbon tetrachloride, ether. So organic compounds are non-polar in nature and most of this organic compound is soluble with non-polar solvent like benzene. The benzene is C6H6 compound. And carbon tetrachloride, ether, these are the solvents. Inorganic compound are polar in nature. In fact, the solubility is generally guided by principle of the dissolved like. Since the organic compound is not a ionic in nature, it is mostly act as a polar conductor. Most of the organic compound are acting as a polar conductor. So far the concerning melting and boiling point, since it is a non-polar, and due to that the force of attraction is more or less quite weak. Certainly, the organic compound are less boiling point and melting point as compared to inorganic compound. The organic compound structures are long chain type due to huge quantity of carbon, hydrogen. Whereas the structure of the inorganic compound are simple, as their combination of the elements are in 1 and 2 quantity. So, most of the organic compound are having a combustion nature, and it is unstable. On imposing the heat, and it can decompose on heating. You see the melting point, boiling point is low. So organic compound are having a different chemical reaction properties, nature of chemical reaction, since there is a covalent bond is there, mostly in the carbon to carbon combination. and it is mostly in aqueous solution in mild condition. When the different organic compound with the same molecular formula exhibit it's called the isomers, and we can name this as a N-butane, N-propane, butane in N number of isomers. The source of organic compound are mostly from the plant, animal, coal tar, petroleum, fermentation, wood, synthetic method. We can also create the organic compound. So the carbon is the essential component constituent of the integral part of the organic compound. Carbon. Without carbon, we cannot expect the organic compound. So, carbon is the integral part. To make the electronic configuration of the organic compound in SPDA. And tetracovalent. The organic compound, as an example, the CH4, that's methane, are having the same identical bond attached with the hydrogen. CH4, C is 1, H is 4, and the C is attached with 4 hydrogen with a single bond. And due to the presence of central part of periodic table, carbon atom have high ionization potential and moderate electron affinity. Carbon is at the center of the periodic table. So, with moderate electron affinity, and it has certain tendency to lose and gain electron. The electronegativity of the carbon is 2.5, which is neither very high nor very low. It's just in middle of a highly electropositive alkali metal or highly electronegative hydrogen metal. So carbon atom is acting just in a midway to form a covalent bond due to a small electronegativity difference between carbon 2.5 and hydrogen 2.1. So mostly it is a tetrahedral in nature with the support similar phases. since the carbon is hard and very small atomic radius, there is an overlapping half-filled atomic orbitals of carbon atom. It is quite acidic because radius is very small. So, what is the reason about the existence of everywhere around the world of organic compound? That is the catalysis properties of the organic compound. That is due to the small radius inside of the carbon and tetravalency. Tetravalency, carbon versus 4, it's have a unique property combining with other carbon atom, forming very long chain and branches of chain, a ring of all size. Ability to form carbon from a long chain and large ring is called catenation. That is catenation properties. This depends upon the available large number of carbon. That is explained as a tetracovalent carbon formation of a strong carbon-carbon bond. And due to that property, the carbon can make a long chain, a straight chain, and also can make the ring type, closed loop ring type structure. Another reason for abundance of organic compound, it is isomeric in nature. Just I told you N butane, N propane. And two compounds are said to be isomer if they have the same molecular formula but different arrangement of it. So ethanol, methoxymethane, both are the same looking formula C2H6O but different structure. So we can say that ethanol and methoxymethane is the isomers of each other, and it's have a multiple bonding, double bond, triple bond properties such as tetravalency. Due to tetravalency, it is to make the multiple bond of double bond, triple bond to make the possible structure. The carbon impurity is 2.5. It is neither very strong nor a very high size, of very small size, radius are, and make a strong covalent with hydrogen and oxygen, nitrogen, other atoms, and also add the number of the carbon compound. So, or reacting with the hydrogen, it is very, very comfortable since this electronegativity is 2.5. Hybridization is the process mixing of orbital of same atom with slight difference in energy. so as to redistribute their energy and give new orbital of equivalent energy and shape. That you can say the sp3 hybridations of the alkene, sp2 hydrogen of the alkene, and sp hydrogen in alkyne. You have to remember it that hybridization is what? What are the alkene, alkyne, hybridization name? We will discuss later on about the mixing atomic orbitals. Let us look at classification of organic compound. We can classify the organic compound by the structural method based upon the structure. And on the base of the functional group. So, when we say an organic compound is open chain, it is not like the hexagon closed chain. It is a straight line chain. That is called aliphatic compound. And that compound which make a closed chain is called aromatic compound. Again, we can say the butane, N-propyl, iodide, acetone. These are the aliphatic compound, is an open chain. And the closed chain cyclic compound are two types. There is carbocyclic, homocyclic, and heterocyclic. The closed chain cyclic compound are in a closed loop. The carbocyclic compound, the homocyclic or carbocyclic compound, can be divided into further two groups. Alicyclic and aromatic. Alicyclic is a chain of contain of ring of 3 or more carbons. There is cyclopropane, cyclobutane, cyclohexane, like this. And second is aromatic compound. This compound consists of at least one benzene ring. That benzene is C6H6. If one benzene, it is called monocyclic. If two benzene, it is called bicyclic. That name is naphthalene. 3 benzene, that is called tricyclic. Example addressing. So in one benzene C6H6, if I replace one H from there, the C6H5, then that compound can accept one group of COH in O2 or OH. When the COH combined with that one replace H of the carbon, the C6H6 benzene, when one H have replaced by the acid group called COOH, that will become C6H5COH and it is called the acid benzoic acid. When H is replaced with nitrogen dioxide, one H is replaced with nitrogen dioxide, then it is called nitrobenzene. One H is replaced by a OH hydroxide, then it is called phenol. Is it clear? So, next is heterocyclic compound. Till now we talked about the aliphatic compound. The aliphatic compound are two types: homocyclic, carbocyclic, and heterocyclic. And the carbocyclic are two types: alicyclic and aromatic. Alicyclic, where benzene C6H is not available, but it is a ring of 3 and more carbons. It may be tri, tetra, cyclohexane. So an aromatic one, aromatic are at least one benzene ring should be there. What is benzene ring? That is C6H6. That every CH are having single bond and covalent bond. C to C bond, single bond and covalent bond. Undoubtedly, CH are having the single bond. And when one of the H is replaced by the COH acid group, then it will become the primary basic benzoic acid. When the one H is replaced by the nitrogen dioxide, then it is called the nitrobenzene. And when one of the hydrogen is replaced by a hydroxyl group, then we will call it phenol. So what is a heterocyclic compound? The heterocyclic compound are the cyclic compound, having ring or ring built of more than one kind of atom. Most common hetero atom beside the carbon are oxygen, nitrogen, sulfur. inorganic. Examples of these class are furan, pyrrole, thiopane, pyridine, indole, and like this. So what we got? The organic compound is classified as structures, open chain, alkylic or aliphatic compound, and closed chain cyclic compound. The closed chain are divided into homocyclic compound and heterocyclic compound. Homocyclic compound divided into two types: alicyclic compound and aromatic compound. An aromatic compound divided into two types: benzoyl aromatic compound and non-benzoyl aromatic compound. So aliphatic compound are alkane, alkene, alkyne. So alkane are the hydrocarbon in which all the bonds are single bond. That is, you can say the CH3 and CH3 are connected here. CH3 and CH3 are connected with the carbon to carbon. All are single bond. If I remove this H, then this bond will go to mix with here, because hydrogen carbon cannot mix with the covalent bond. Then it becomes a double bond. What will happen? Look, alkene aliphatic is a double bond. Again, if I replace another H, here H, to liberate hydrogen, H2, then alkyne will come, it becomes the triple bond. So you understood the aliphatic, alkane single bond, alkene double bond, and alkyne triple bond. How this bond is forming on replacing the H2? Single bond, alkane double bond replacing the hydrogen, and alkyne triple bond replacing the hydrogen. So it is triple bond alkyne. And what is hydrocarbon aromatic? It is benzene, I told you. The C6H6. That C are making the covalent bond here. It is a closed link. And making the single valent, the covalent, single valent. This portion you can understand C. Okay? So C, this crossing is C. 1, 2, 3, 4, 5, 6. C6 and H6. So this is benzene is the starting of the aromatic compound. So we are now going to classify that I told you earlier hydrocarbon with the functional group. Most of the organic compound consists of two parts. Which is known as group or radical. That group are responsible for properties of the compound. One group is generally alkyl group, that is R. that we can say CH3, that R is bonded single bonded with the H. That H is what? Functional. And X is what? Halide. The group is called the functional group, which is used for the chemical properties of the compound. So what we got? A functional group is an atom or group of atom. If I say CH3, the second group of atom is double carbon, then what will become? C2H5. Like this. CH2 will be added. CH3 dash CH2. Okay. Every time CH2 will be added. So a functional group is an atom or group of atom in molecule that give the molecule in statistics and chemical properties. Because its total depends upon the bonding arrangement. The state, melting point, boiling point. The survey classifies organic compound into classes or families. Like alkene, alkyne, alkyne. The class carboxylic, sulfuric, halide, alcohol, aldehyde, ketone, caroketone, ether, and thiamine. Amines, cyanide, nitrite, nitro compound, ester, acid halide. So the reaction that takes place is term of substitution method. Which will be substituted? The H will be substituted by the X. On periodic table, both are in either side. So they can susceptibility to substitute, replace each other. And one of hydrogen is substituted by the other of atom group X. That if I react with the C2H5 ethane with chlorine, then chloroethane will be created. That one H is replaced by the chlorine and become the chloroethane and make the hydrochloric acid. Then H is substituted by the chlorine. Both are H and chlorine are either side of the periodic table. So when the alkane, when you say the alkane is the RH. Alkene, I told you, it is RH with double bond. Alkyne, RH with triple bond. And aromatic is a chain of double bond. One single bond, one double bond. So, alcohol, when H is substituted with the R by the hydroxyl group, it's become alcohol. Alkyl halide, alkyl R is substituted by the halogen group, that is chlorine, bromine, iodine. that we call alkyl halide. When amines, when the H is replaced by the NH2, the primary amines, the secondary amines, it is NH. H have the 3 valency and H2 have the 2 valency. The difference is 1 valency remaining and can tie with the R. Now N has the 3 valency and H has the 1 valency. So NH have a remaining 2, so it requires 2 R. It is combined with the R, NH, R. You can write the R, NH, R, the secondary amine. And tertiary amine, there is no H, only N. The N has the 3 valency, that we can combine with the 3R. When 2R are interconnected with the O, then we will get the ether. Clear? So, carbonyl group is what? This carbon required 4 valence, 2 is tied with oxygen, 1 remaining and 1 air remaining, that you can combine anything. That is called the carbonyl group. And when if 1 R is kept here, the remaining is to take something, that is called the alkyl group. Just differentiate what is the difference between the carbonyl and alkyl group. So the carbonyl group, we can keep both of that RR, or we can keep both of that HH or OH, whatever the single radicals. Okay? But in alkyl group there must be a 1 R. So, when alkyl group is connected with the, previously it was alkyl group, there was a R, now they can connect with the H anything of the radicals, then it becomes aldehyde. When is connected with the another R, that will become ketone, and it connected with the hydroxyl group, that is become the carboxylic acid, COOH. So alkyl, carbonyl, you see the both side B, and the alkyl is what? 1 R is there. When alkyl is connected with the H, become aldehyde. When both are R, become ketone. And when alkyl connected with the OH, it become carboxylic acid. So, when alkyl add with the OR, that is also same like this R, this is R dash, that is not the ester. You know the ester of ester. And when this alkyl group connected with the NH2, it is not amine. So, alkane, when C is 1, then 4H is required, that it is CS4, that is called methane. When C is 2, then H become 6 because double bond will took place, 3 one side, 3 another side, in between middle side, C with the double bond. And propane you just divide better to understand that CH3 remaining what? CH2. Okay? Because CH2 can combine with the CH3 and both sides require CH3 and CH3 will between the CH2. So methane, the center is black color carbon and both side is the hydrogen. So you understood the methane, all are single bond, the orientation are almost 90 degrees of each other and boiling point is minus 160 degrees centigrade. Now look here, the boiling point increasing, it's minus figure, so you can say it is increasing from ethane to methane to ethane to propane, because propane having the 3 carbon and 1 carbon, this carbon is called CH3R, this is R and it is CH2. CH2 negotiated with the both R. So it is not at all problem with the CH3R, this is R and in between CH2. This is what? CH2. That is what? CH3 and CH3 connected. And that is CH4, that is RH. CH4 is what? RH. So boiling point and no isomer possible for C1, C2, C3 of hydrocarbons. It is not the all are having a different chemical formula. And structure also are different. So these are not the isomers. So isomeric alkane, the butane, is C4. The C4, then how much hydrogen is required? If the CH4, if I write here, say CH4, no? That is methane. Here N is 1. Then what is the value of H of that 4? That you can say, if N is 1, then H is what? H is equal to 2N plus 2. When C becomes 2, then H becomes 6. When C becomes 3, then H becomes 6 plus 2, 8. When C becomes 4, H becomes 10. So methane, what will become when C is 1, methane, C is 2, methane, C is 3, propane, C is 4, butane. In cooking gas cylinder, there is a butane. Okay, and C5, pentane. We will discuss about the nomenclature. So to understand how C4H10 have arrived, this is the formula. Okay. So alkynes are having such type of formulas. We will go ahead look. C4H10, that is what? CH3, CH3, okay, and CH2, CH2. Clear? Look here, if this carbon is 3, okay, and this is 3 hydrogen, and if this carbon is 2, CH2, CH2, okay. So, butane, N-butane, okay, CH2, CH2, okay. So, as per the arrangement of the carbon hydrogen, look, boiling point. Okay. How it have been done? There is also C4. Okay. And all are C3. The 4 carbon 3, 3, 3, 9, 1, 10 hydrogen. The formula both for same, but the structure are different and causes the properties of boiling point. Minus 0.4, minus 10. Due to the structure, the boiling point decreases. Understand? Same formula. With the change of the structure, the boiling point decreases. So higher alkane, the pentane, I told you the 5 is pentane. The formula is CN2N plus 1, where when N beyond N is greater than 4, up to butane is okay. When N is greater than 4, then what will happen? N pentane. Look here. This is CH3 and this is CH2, CH3, and all are interconnected with CH2 because CH2 having the remaining 2 bonds, one for this side, one for this side, one for this side, one for this side. Always connected with the C to C, okay? And with that. So after that, it is after N equal to 4, it is look like the this zigzag. What I call that zigzag? Open chain. So N hexane where C equal to 6, then we keep the R both side outside. Then when hexane is there, the C6 and how many H? 12 plus 2, 14. Okay. Then 2 H6 H have gone with the R and in middle CH2, 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 CH2. No problem. Then heptane. When C is 7, then how many H should be there for alkane? Then is 2N plus 2, then 14 plus 2, 16. So outer side CH3, okay, inner side interconnected with the bond, okay, CH2. So we have the open chain. You might have understood that isomer of C5H12. You will get found the C5H12 are the same formula with the different arrangement of the structure, which causes the changes in its property. So it is called isomer. So undoubtedly that follow the alkane, this is alkane, always check this formula whether it is alkane, alkene, alkyne, that CN plus H2N plus 2, okay? This satisfies that rule. So it is alkane, okay? Because 5 to 10 plus 2 equal to 12. So it is alkane. Let us see. That N pentane is open chain. Now we can arrange this. That CH3 will take one side, making a bracket 2. Okay. And another CH3 you have generated, that one CH2 becomes CH. Okay, and CH2. Then what will happen? Isopentane. Okay, are you clear? CH3 to CH, CH to CH. Clear? That CH3 is connected here. And same like we can do 4 CH3. Because CH3 has a one valency. Okay. So here CH3 okay, and here C, okay, then interact with the CH2, okay, okay. Again, it is open. Understand? So you can put here CH3 neopentane. Why it is iso? That is connected with the first. You have go to left to right. It is here in first. We can keep this in here also. The name will change. Okay. So the section, how many isomers? The number of isomeric alkane increases as number of the carbon increases. Of course, the isomers start from the n greater than 4. And that number of the isomers, you have seen the previously isomers were 2 for the 3, and before that it had 2 isomers, and now it's become the 3 isomer, and when it's become the 6, then isomer will increase. How? There is no simple way to predict how many isomers there are for a particular molecular formula. Totally depend upon CH4, C2H6, C3H till up to that 1, and butane 2, and pentane 3, hexane 5, and C7 it become 9. Till up to this it is 1. After that 1 increase, after that 2 increase, after that there is a 1 increase, okay, there is also 1 increase, this 2 increase, this is 4 increase. So what? How many isomers isomer with the composition 6 can be drawn. That is so images. So structure and bonding in alkene. Now we are talking about the alkane. Now it is alkene where the double bond are there. Bond angle are alkene. One like this when this like this is the they should combine with something. Okay. So for that position it is 117. Okay. So C to C bond is no problem. If I make it center, then this bond, then this. Okay, this angle rotation. Okay. So when we arrange like this, 121 and CH is 110 and CC is this bond is what? Bond distance. This is a distance series. Okay. So the framework of sigma bond. What is sigma bond? Each carbon in sp2 hybridized. I told you earlier that you should keep in the mind the alkane sp3, alkene sp2 and alkyne sp1. Keep in your mind. You know IIT or JEE, WJEE or any engineering or in also in IES exam after BTech or anything BSc or MSc, that you have to keep it in your mind. 1 and 2 marks will get. So chemical bonding, when we study, you will understand what is sigma bond. Let me explain a little bit about the sigma bond. That ethylene is a tie-up, a rod of some white that is very difficult to twist. One side clockwise, other side anti-clockwise, rotate. It's difficult. If it is a square, it will twist the opposite angle, diagonal angle. One will compress and one will increase. But if it is a circle, every side will be equally shared because there is a strike in the circle inner wall at 90 degrees on each and every point. That is the reason your cooking gas cylinder upper and bottom side are in volume. That is called balloon. What are the gas tanker? It is called balloon and looking like balloon. So that inner pressure of the gas make equal pressure on the gas wall. And there is no question of localizing the pores to crack the balloon, to crack the cylinder. So each carbon has a half-filled p orbital. That is half-filled. and making tie each other. That is the isomerism in alkene. Isomers are different compounds that have the same molecular formula. Same quantity of carbohydrates, but different structure and compound with the name of structure. So isomers which follow certain rules and regulations constitute isomers, and some follow the straightforward manner, sis-isomers. So suppose any compound whose C value more than 4, what is the structure shape? For that purpose we require some test. That Excel diamerism technique is introduced. It may be the formula shape, structure may be different, and how to examine the structure, Excel diamerism technique. Electron beam scattering technique, nuclear magnetic compound magnetic resonance technique, and hard working chemists were do like that. So C4H10O and the 135 from these C10H13ON, like that. Methyl alcohol, dimethyl alcohol. Alcohol, I told you, that have hydroxyl group. Methyl is C2H5, R, and CH, then C2H5 plus OH added, ethyl alcohol. When 2 methyl alcohol when 2 disposing one that alternate with the O, replacing the hydroxyl H4, then it becomes the methyl R, C. Okay. So ether, diethyl ether is same like we are having classification of isomers, that is constitutional isomers and sis-isomers. The structural isomers, constitutional isomers, chain isomer, position isomer, and functional isomer, metamerism, tautomerism, and ring chain isomer. And in the stereoisomer, there is a geometric isomer and optical isomer. There is a geometric shape, symmetry, and optical mirror optical symmetry. So each have a different connectivity, different arrangement of atom in space. Consider the isomeric alkene of molecule formula C4H8. What is this? Cis-2-butane. Cis CH3 R and R are one side. Total carbon is 4. And there is a double bond. So it's not the butane, it is butene in. And since R is one side, then you can say it is cis-butane. Cis-butene, because it is double bond. So it is also double bond and 4 carbon butene. That where is the position of C2H5 attached? Okay, in one side. The one butene. Here is what? C4. Okay. Then what is this? 2-methyl. This is what? CH3 what? Methyl. This is called met. Okay. R is met. Then how many methyl are there? 2 methyl. Okay. Remaining propane. Because N is there. Propane, not propane, propine, because it is double bond. Propane is single bond. Propine is double bond. So trans, here R is opposite side, transverse side. Okay, so it's become the trans-2-butane, cis-2-butane in same side. You understand? Let us look constitutional isomer. That one butane, methyl propene, butene, and cis-2-butene. This is a trans. What is sis-isomer? So that strict isomer two type. I told you geometric isomer and optical isomer. One is decided in that previously geometric isomer. The geometric position of that, and the optical isomer is a mirror. You stand the mirror, the laser look at the right side. And the structural isomers are chain-like isomers, position isomers, okay, functional isomers, metabolism, deuterabolism. These are the structural constitutional isomers. The chain like already I had told you till up to 4, n equal to 4, that is a chain type. Okay. C5. Okay. you know how to construct the chain type structures of isomers, both sides CH3, okay, and between CH2 on the alkane, okay, it will satisfy the formula C4, look at me, C4, look at me, C4 H2N. So it is isomers. We have a lot of way to go about the isomers, and we will understand tomorrow morning again. Okay? Morning. And we will finish the isomerism. Very interesting. Okay. It is very interesting chapter. If you understand this startup thing of the organic chemistry, then it will help you a lot. So take it serious and try to understand it. Tomorrow we will finish the isomerisms and the alkene and alkyne and alkane, all the formula and the properties and applications also. Try to come. Okay.